those presenters have made everyone given in a statement, apart from Stuart. Probably the statement was pretty clear what he was to say. And I would ask you, maybe amongst each other, to challenge or to comment the statement, and then I would open the discussion. Sorry. Open the discussion or your contributions to actively participate. It's not so much about questions, but you can also make your remarks. So, Stuart's comments.
No, I thought the purpose of this was the discussion, so there's more time now for discussion.
Okay, Anders.
The statements either are too challenging or not challenging at all.
Speak up. It's okay.
So, Stuart, oh, that was a bit too loud. How much trickier is it to optimize grinding if you have mixed traffic compared to if you have fairly uniform as light rail or heavy haul?
I think as far as this is concerned, and we're talking about particularly here reprofiling for corrugation,
Yes.
Then the evidence is pretty clear that corrugation is a very much worse problem where you do have consistent traffic. And if you have mixed traffic of almost any sort, then corrugation is much less severe a problem. So it's a bit like the discussion this morning in the plenary session. The more variety that you can get for almost anything, the better the life is for your wheel rail contact. And the same for corrugation. Anybody else want to comment?
Comments? Martin?
Martin Hinch. Andy, I was thinking about this whole life rail model for this premium rail. I've been looking in literature myself also, and it's very difficult to find anything else validated than the 220. So I was just wondering, where did you get the graph from? How was it derived?
So that is in T775, I think, which is an RSSB report, which was done as part of that work. I'm not sure it's ever been published other than by the RSSB. I think, to be honest, Network Rail put in a lot of 335 following that and have never had any problems with it and seen the benefits with it. I think they had one site where they did what I was talking about and moved it from WARE to RCF, but that was it. But I don't know whether that's actually been published anywhere other than that report.
But was it work done by Huddersfield that gave
Yeah,
that?
for the RSSB. So it's a T-numbered report.
Thank you.
Did they publish? Or is it a confidential report?
That's a good question. I think it'll be, if you're a member of the RSSB in the UK, it will have been available. But
For members.
in Spark, there you go. There's someone for the RSSB all the time.
There was a question here. Can you have a microphone? Well,
Yes, I actually did that work and I can send you a copy of it. I was a subcontractor to Huddersfield.
Okay. There you go.
thank you. A question in the far back? Or a comment?
This is the question to Mr. Steenberg. Did I understand you correctly that you say that we will not see a material that will match the magic wear rate we are hunting for? And if this is what you said, how do you come to this conclusion?
Well, if we talk in terms of materials, I think that a material that matches the magic wear rate might be found, might be identified. But in terms of rail profiles, I don't think that such a profile exists, because the wear is always non-uniform across the profile. So even if you would achieve a magic wear rate in terms of materials, in terms of profiles you can't obtain it, but I think that you can get much closer than what we have right now.
Okay. Thank you.
Yeah.
Can I?
Yes,
Of course.
please.
Can I just-
This is a panel discussion.
I mean, in defence of the magic wear rate, and I don't think it needs much defence, my understanding of it was that you weren't looking, if you could get it in one material, then you were very lucky. And so the whole purpose of this was that you would increase the wear rate artificially by grinding to get rid of cracks. So my understanding of that bit of your talk, Michael, was that you were looking at having one material that had a balance between wear and rolling contact fatigue, but in reality, what you'd be doing is actually increasing the wear by grinding.
But yeah, what I maybe it's good to say then also that the only, let me say it differently, only natural wear is surface friendly. Let me say it like this, is the most surface friendly way you can treat a surface, just by natural wear. So that's also the reason why I think trying to get as close as possible to the magic wear rate makes sense. That.
Yeah. A question there.
Yep. Sorry, yeah. One for Andy. I noticed you said going forward you were looking to include onboard adhesion.
Mm-hmm.
Have you guys also considered onboard topper rail or any other?
They're all the same thing to me.
Are they?
Both.
That's probably another discussion we can have then. Yeah. Okay. But yeah. Okay. So you are.
Yeah, I mean,
Okay,
if
may I take this chance to share my new grinding method for the rail corrugation? You know, wait, it's working?
Yeah.
Okay. So my method is just to do like this for the grinding of the rail corrugation. Why do we not use the miller wheels, like miller wheels? Maybe put 4 or 5, 6 miller wheels at a constant level, and to do the grinding of to remove the rail corrugation. It's more easier. Why?
it is easier, but
It's
they're
easier?
generally more expensive machines.
It's expensive.
And you have to have reasonable track conditions to do it on.
Really, but we can use the small diameter millers, 6 millers.
Well, they've actually now, the original millers, and someone more qualified than me could comment, had quite small wheels, and that was the issue we had on not so good track. Because of the amount of vertical deflection you would get, you would rip them to pieces, and now they've got much bigger wheels, so you take less cut per head.
Yeah, we are talking about technologies. There was a question in the middle, which I have overseen the person. There, in the center.
Thank you. Hendrik Jan de Graaf. I have a question for Michael Steenbergen. If I understood your presentation, the rail grinding machines, they repair the track a little bit, but they make the conditions to hire them soon in time for a second time and a third time, and you never get rid of them. If it was your track, would you allow grinding machines in the track? Can they fulfill the requirements you would require to the surface, how they leave it behind? Or is it end of technique and we need to go to new techniques which leave the conditions in a better case?
I think there's a lot to say about this. It's a very good question, by the way. I think in the large majority of cases, we can leave the grinding machines where they are. But I think also in a dedicated portions of the field or the area, we should look into more sophisticated solutions. And that's where the problems arise. So you have head-hardened rails, you have rolling contact fatigue damage. There you need at least stricter norms and maybe new technologies. So I think there is a lot of potential, but I would not say that we should ban the grinding machine from our network. That goes too far.
Okay, thank you.
Any other question? Yes, Elena.
Trying to get into the concept of statements and discussion around. I would like to ask the last speaker, Mikhail, could you please elaborate on your statement? And if you like, you had the slide with like several statements. Maybe you want to elaborate on those as well.
Yeah. Can I
The
get
last
back to
presentation,
the last
please.
slide, please? Can I do this? Okay, sorry. Yeah. Yeah, basically there are a number of propositions there, and if I understood you correctly, you asked me to elaborate on the last one? Yeah. Well, I think this is the red line through my whole presentation. If you stop thinking in terms of reprofiling, I think the concept of reprofiling is only suitable for, in a world of where you have only where. I think we have to think in terms of both where and RCF, and in the RCF world, we have to think differently. We have to think in terms of surface conditioning. How are you going to condition the surface to leave it behind in such a way that the life cycle is really, you really go back to zero again instead of to 50% or to 80%, I don't know. And even if we can't go back to the zero again, we should try to get as close as possible. And there I think is a lot of potential, because just right now we are just reprofiling everywhere.
May I make a short comment, not sitting
Of
in
course.
the audience, but this morning we were talking about rail reprofiling, and we were saying that there is some big potential in setting the right specifications. Mind, aggressive grinding is not necessarily aggressive, and milling is not necessarily smooth. So each of the technologies has one. And I would just also mention that I was thinking of rail conditioning on other things like top-of-rail friction management, which also could contribute, even together with other technologies of reprofiling.
But my point is that if you talk about reprofiling in an RCF world, I think your starting point is wrong. I mean, we talk about the conditions of the surface which govern the life cycle behavior. And if you are reprofiling a profile which is subject to RCF, you might do that in a good way, in a proper way. It's better to use the right words also.
If you have the perfect surface, you are assuming that you do not have any fatigue going on and any cracks building up.
No, that you postpone them as long as possible.
But then you have to do something, and this is reprofiling.
Or treatment of the surface.
How would you treat it if you have the cracks already there? If it's not reprofiling?
Well, reprofiling, the word reprofiling suggests that you are changing the profile, you change your profile also.
So then we call this what we do by metal removal, something different. We have to look for a new term. Okay,
I think
we've got 1 minute and 20 seconds. Is anyone willing to use that?
Be careful.
Gravity works everywhere.
Yes, Richard. A reprofiler.
No. So I think the question of interpreting what you mean by reprofiling, but that's not the question. I have a question for Andy. Andy, you said the data for T-gamma for that HP rail is coming out of a project, correct?
Yes.
Do you know how big the database is for the HP rail is versus for a standard carbon rail? Because I guess for a standard carbon rail, it's like huge, immense databases, and T-gamma is very phenomenologically, yeah? So I would guess that if the databases for the HP rail is very small, which I would assume, do you think that the model and the shape for the HP rail might change over time?
Absolutely, and if you want to go into that report as well, you'll see lots of other proposed changes about looking at angle of creep force. What my job is to do is to turn around to the head of track and say, if you do this much grinding a year, you won't re-rail anything for RCF. So where the model and the realities of running a railway meet is where we have to go to. And I'm pretty happy with the results we've got that I could show. I mean, those results are from round curves on the subsurface, where we've got sub 200 meter radius curves, lots of traction, I could grind them every 6 months and they would never be perfect, but I know to put a machine there once a year, and that gets us over the line.
Okay, I have to stop at that
Thanks.
moment. We have got about 10 minutes time to change for sessions to smoke or whatever. Coffee will be after the next session. Thank you very much for the speakers. A round of applause.